Hey folks, welcome back for another episode of Code Club. In today's episode, I'm going to be trying to recreate a figure from this paper published in the journal M Systems. The paper was titled L-tryptophan and Copper Interactions Linked to Reduced Colobactin Genotoxicity in PKS plus Escherichia coli. It was published by Charlie Bain and colleagues, and this just came out this past fall in September. So I don't know a whole lot about what's going on in this paper. PKS plus E. coli, it has been linked to colon tumorigenesis, at least in mice, and I think maybe in humans as well at this point. And so this is an interesting organism because when it becomes part of the gut microbiome, it might have something to do with tumorigenesis. And so that's interesting, that's important, right? And so as I was kind of looking through this paper, figure 5 caught my eye. And so where is it? Down here, right? And so this is part of a multi-panel figure. You'll notice that a lot of their figures in this paper look a lot like something generated by ggplot2. And so this is figure 5D. And again, this caught my eye for a variety of reasons. So first of all, what is it? It's a box plot on top of data. So they are looking at different levels of copper, as well as the fluorescent readout from an assay. So the orange, the 7H4M, is a control producing fluorescence at the same level regardless of the copper concentration, whereas the CLPB17 shows decreased activity, decreased fluorescence output as part of the cleavage as you get to higher levels of copper, right? And so this fluorescence on the y-axis is relative to the case where there's no copper in the media. That's all I'm going to say. I'm kind of fumbling through my own explanation because I don't totally understand what they're doing here, but I thought it made for a very interesting figure to try to recreate. There are a few things that I kind of wondered how I would go about doing. One thing that stands out to me is that they've got points for showing their data. They have about N of 3 for each of their copper concentrations and combinations with the reagent. One small critique I would give is that a box plot is kind of pointless when you only have 3 points, because as you can see, like in this example here, each of the points, the point at the lowest level is the minimum, the highest level is the maximum, and the other point is going to fall at the median just by definition. If you kind of look at all these box plots, you see the same type of thing. Whatever, that's not a big deal. But it's interesting that they have the data on top of the box plot. Something that's interesting about this to me is that within ggplot2, we only have 2 color-related aesthetics, right? We have color, which when you think about a box plot, the color is the framing of the box plot, right? The min, the max, the median, the interquartile range, right? But for the plotting symbol, we typically think of like geom jitter, geom point, that if you're using a round plotting symbol, like say number 18 or so, that the color of the point also gets set by the color aesthetic. And so it's interesting to me that they're doing different things with color with these different geoms. And so I'm curious how one would do that. The other thing I notice is that all of these box plots appear to be evenly spaced across the x-axis. Normally when you make a box plot and you have 2 treatment groups, across the x-axis, you'll certainly get the spacing, but then within the x-axis position, you'll get like a dodging of the 2 treatment groups, but they'll be closer to each other than they are to the next group, right? Like there should be a bigger gap in here, I feel, than there is. And so the gap here is the same as here, here, right? And so that's interesting to me. One of the other things that's interesting to me is, as we've seen in other recent episodes, they have the tick mark between their values for the copper, right? And so that's interesting. It's interesting that this is a discrete scale effectively, but it's really a log scale, right? They go from 0, so none, to 0.003, 0.01, 0.03, 0.3, 30, 300, right? And so that is kind of like a log 10 scale, and they didn't make use of that for whatever reason. The other thing that's cool is that the x-axis label is in line with the x-axis text, right? Normally we'd expect to see copper micromole down here, but instead it's off to the left, right? So that's interesting. They also put the legend inside the plotting window. So there's a variety of things to work on here. I'd say that of the many figures that we've been working on, this is one of the few that is most obviously made in ggplot2. And so I'm going to head over to RStudio. I have simulated the data from this figure and included it here in this script. I'm calling it copper floor, CU floor. If you want to get this script as well as all the code that I'm generating today, please go down below in the description for today's episode. You'll see a blog post that goes to a page that has all the code. Also down there is a link to a newsletter article that I wrote and sent out to people describing at a very high level how I would go about taking on this figure. And so I will be doing that today. So let's go ahead and load all this data in the tidyverse. And again, if we look at CU floor, we see that it is a tibble, right? And we've got 42 rows. So we've got the 7H4M, as well as the other treatment, the CLPB17. Now we have different copper concentrations and different fluorescences, and we basically have an N of 3 for each combination of copper and treatment. Let's think about how I would normally do this, right? And so that doesn't mean that's the way it should be done, but I don't know, it's just kind of the way that comes naturally to me. If we do ggplot AES, then on the x-axis, we can put copper, and then Y be the fluorescence, and then the color could be the treatment. And then let's go ahead and do geom boxplot. And what we get are two values, 100 and 200. And I think that is because we're treating copper as a continuous variable, and it is basically forcing it into being a discrete variable, right? So let's go ahead then and force copper to be a discrete variable. And we can do that up here where we create the data frame by doing as.character on that. So basically we're going to convert all of these concentrations into character values. And so again, if we look at copper floor, we now see that copper itself is of type character. Okay, so now when we run this, we now get our box plots, right? And so you can hopefully see that the two treatment boxes are right next to each other, at least up at 0, right? And that there's then a space between 0 and then 0.03, right? But there is a space, right? And so if we look back at the original, we see that the space between all these values is the same. There's a way to pull this off, right? So we could do geom boxplot position equals position dodge. We could then do width equals 0.2. Okay, that makes them overlap more. All right, that was a nice try. Let's go and let's try 0.8. It's a little bit further apart. I think 1 gets them a bit apart more, right? So those look a lot like they are actually evenly spaced in between. Another way that you might think about doing this is, again, if we think about copper floor, that we could pipe that to a mutate, and then we could say copper treatment. We could then use paste to do copper treatment. And let me make sure those are the right columns. Yeah, treatment and copper. Good. Yeah, we'll take copper floor, and then on the x-axis, we could do copper treatment, the y-axis fluorescence, color treatment, and then we don't need to do any of this dodging. Oh, it's unhappy because I have too many parentheses. And so that gives us, again, a very similar look. If I had to guess, they probably did it this way for some reason. Just because I don't know why you would use position dodge to get a space between the two treatment groups that you're trying to dodge. I don't know why you would do that anyway, but anyway, it's not a judgment. It's just trying to figure out how they did it. And so, as I've shown, there's two ways to do that. One would be to make a new variable, copper treatment, that we can then array across the x-axis. The other approach would be to not do this mutate and to instead use position dodge within geom boxplot. So the risk of doing it this way with copper treatment is that the x-axis is going to be sorted. And so let's zoom in on this and make sure that it actually has things in the right order. And so I think it does, right? So I see 30, 30, 300, 300, and it does have things in the right order. And so that works well because I put the copper first. If I had put the treatment first, then we would have all of the salmon colored bars together and then all of the teal colored bars together. Anyway, I'm probably making too big of a deal out of this. I'm going to roll with doing this approach because that's what I talked about in the newsletter that hopefully you're subscribing to. So now we have some work to go about making this look a bit more attractive. I'm going to go ahead and save this with ggsave. I'll call it boxplot dilution.png. Earlier, I checked the aspect ratio, and I'm going to use a width of 7.5 and a height of 3.68. And so there is our plot. So this is where we're at, and this is where we hope to go. They do have a pretty minimal background. I'm curious what theme they might have used. So let's see if we could go ahead and do theme classic. I don't think that's going to work because theme classic doesn't close off the box. That might be what they did, but let's try a different theme. So let's do theme minimal. That's not right. Let's do theme BW. And I think that's actually pretty close, except I think they turned off the grid lines, right? So I'm going to go with theme BW and then turn off the grid lines. And we can do that by adding theme, and we'll do panel.grid.major equals element blank. And it appears we still have a minor grid line. So let's go ahead and do panel.grid equals element blank. That then gets rid of all of the grid lines. So let's go ahead and move the legend inside of the plotting window. We'll also want to get rid of the title on our legend. And so we can do that by coming in here, and we'll do labs color equals null. That null will get rid of the title. So now we see that's gone. We'll now want to move the legend inside of the plotting window. So we'll do legend.position equals inside, and then we'll do legend.position inside, and then it's going to be, so the coordinate that we're going to give it is where it's centered at. I think it's y is about 0.6, and x, let's say, is like 0.8. So we'll do 0.8, 0.6. And so I think the y position is pretty good, but it needs to go to the right a bit. And so let's go ahead and make that 0.9. And it's probably 0.85. Let's do that. They also have a box around their legend. So we'll do legend.background equals element rect, color equals black. So it appears that their font on their legend is bigger than ours. So let's go ahead and do legend.text equals element text size equals 12. I guessed that, and that worked pretty well. Let's also go ahead and make the symbol a bit bigger, the key. And so we can do legend.key.size equals unit. Let's do 14. Yeah, I need a unit. So we'll do units equals PT. So I think that actually made it smaller. Let's bump that up to 18. I think it could be even bigger. Let's put that up to 20. So that key size is still bugging me a bit. Let's go up to 25, and I think that looks pretty good. Their margin does seem to be a bit tighter on the legend box. We'll do legend.margin equals margin, and then I like to make everything 0 and then work out from there because it's not immediately clear to me what the default is. Okay, so that really collapses it in. So let's make it 1 all the way around. Thinking maybe it needs to be 2 on the left and right. So top, right, bottom, left. Let's turn our attention then to our y-axis. And so it needs to be fluorescence % no copper. And so let's come back up to labs. And then here we'll do y equals, and I can never spell fluorescence right, so I'll copy and paste. Fluorescence. And then it's % no CU. Our font needs to be a little bit stronger than what it currently is. And so we'll do that with axis.title equals element text size equals 14. I think it could probably be a little bit bigger. So instead of 14, let's make it 16. So the y-axis text needs to be strengthened as well. So let's do axis.text element text size equals 12, And I think that looks pretty close to the same size. And their tick marks are a bit thicker and longer than ours. So let's go ahead then and do axis.ticks.y equals element line. And then we'll do line width equals 1.5. That looks a good thickness, but theirs are longer. So we'll do axis.ticks.length .y. And we'll do unit. And let's do 10 pt. I have no idea what it should be. I'm going to put in 10 and see where that gets us. It's not 10. It's probably like 5. Let's try 5. It's probably 7. Yeah, 7 looks right. There does appear to be a bit of a margin around their text. So we could add that with our axis text. I'm going to make this Y to make it more specific. So let's go ahead then and do margin equals, and that's to the right. So we'll do margin R equals 5. So that put a bit of space in between. And I'm reminded that this text appears to be a different shade than our tick mark. We need that text to be black. So we'll do color equals black. And let's put this on a separate line. Very good. And so I think our y-axis matches their y-axis very nicely now. Now what we want to think about is the x-axis. And so I'm going to go ahead and get rid of this copper treatment x-axis label. And we can do that back up here with labs like we saw with color. We can do x equals null. For sure, we'll be adding the copper in micromolar to the bottom left before too long. But we need to go ahead and put in our labels across the x-axis. So I think what I'll do is go ahead and scrub the x-axis labels and the tick marks, because the tick marks need to fall between the concentration groupings, right? And so, again, if I had to guess, they probably laid this down using something maybe like annotate or geom text, although I'm not really sure what they did. So let's go ahead and do that. We'll go ahead and clean that up and remove that by doing axis.ticks.x equals element blank, axis.text.x equals element blank. Oh, and I forgot a comma here. So that got rid of everything on the x-axis. Now what I want to do is go ahead and put in those labels across the x-axis. What we'll do, I think, is add an annotate function. And we'll use geom text. And the x is going to be, if I had to guess, this is always a bit of a guess for me. This is 1, 2, 3, 4, 5, right? At between 1 and 2 would be 1.5, 2.5. Actually, it's going to be 3.5, right? So this would be 1.5, 2, 3, 3.5, and then 5.5, 7.5. And how far out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So out to 13.5. So I'm going to replace all this with a seek 1.5 to 13.5 by 2. And our y, I'm going to leave it inside for now. So let's make it 60. And our label, I'll make the label 0, 0.003, 0.01, 0.03, 0.3, 3, 30, 300. And they don't have a 3. They go from 0.3 to 30. All right, so let's run this and see what we get. And so, yep, that's placing everything in the correct x-axis position. Let's now put it down a layer into, let's probably going to be, let's say 53. So we'll go ahead and do that. We'll do y equals 53, and we'll put all these things for annotate on separate lines. And then we need to add a chord Cartesian, and we'll do clip equals off, and that's a string. And that adds to the bottom of the plot rather than putting this below the plot. So to fix that, we then need to do, so we'll do ylim, and if I had to guess, it goes from 55 to 105. It might be 58 to 103 or something like that, but let's try this. We also have the expand going on the y-axis. So let's go ahead and turn the expand off on the y-axis. And to do that easily without changing the x, I'll do scale y continuous, expand equals c 0, 0. So now our numbers are basically off the bottom of the plot, and we need to add in extra space on the bottom here. Let's add a margin to the bottom. So let's do plot.margin, and we'll do margin, and what I want is the bottom. So let's put that to be 20. Very good. So that pulls it up off the bottom, but I did lose my margins from all the way around. So let's go ahead and put in those other values. So let's make it like 5, 5, 20, and 5. Very good. So that gives us a margin all the way around. So their values are down a little bit, and they're also bigger. So let's come back up to our label, and we'll do size equals 12, which was what we had on the y-axis, and we'll do size.unit equals pt. And that looks pretty good. It could probably move down a smidge. And so, again, I had that at 53. Let's put it at 51. I think it should be 52. Let's do 52, and we'll be good. Great, so that's a good placement. So I want to modify my annotate to see if I can put the copper over here in the bottom left. So let's do that. So we'll add to this CU. We'll do U molar, and I'll fix that in a bit, don't worry. And I will put this to be negative 0.5. So we're gonna have to modify our x-axis limits. So we'll do xlim from 0 to, what is the far end? 14. Oh, and we've got too many things. I think I forgot to remove something from this, right? We need to remove this 1.5. So we still have our expand on, which is why things are kind of moving around too much. So we can go ahead and remove this scale y continuous and add expand equals false. Oh, and I forgot to spell expand correctly. So we'll do that so it doesn't yell at me anymore. And I've got my limit wrong on the end here. So I need to fix that as well as on the left. So let's adjust our x limits. And so I'm going from 0 to 14. This should probably be 0 to 15 on the right side. Okay, maybe not 15, 14 and a half. So we'll do 14.5. That looks good. And then over here, the left limit needs to be moved in a half a unit. So let's do that here. Let's make that 0.5, and that looks really nice. We could probably move the copper over just a hair. And so this first value is at negative 0.5. I'm going to make this 1.5, and then we'll tack on C negative 0.4. Yeah, and I think that looks good. Again, just to kind of explain what I did here, because I did it kind of quickly. This creates a vector of values going from 1.5 to 13.5. I had initially had negative 0.5 for the copper label, but I didn't want it to be right at the edge of the plot. And so I basically concatenated on negative 0.4 so that basically that grows the vector by adding that value to the front. Okay. So now we've got this hideous underscore u for a mu. Let's come back to Google and do Unicode mu. So this is the Unicode 03BC. And so what we can do is \u 03BC. I think this should work. And that gets us a mu. Winning, right? Cool. Now what we need to do is go ahead and add our tick marks along the x-axis. And this is, again, going to be very similar to what we'd seen previously with the annotate. And so we'll come in here and do annotate, segment, and we need x positions, we need y positions, actually we need x start positions, we need x end positions, y start, y end. So y is going to start at the bottom limit, which is 55, and end, well, we have 52 here, right? But that's probably too far down. We probably only want it to go down, maybe say 1 unit. So let's make it go down to 54. And then our x and our x end values are going to be the same. And those are going to be, so this is 2, 4, 6, 8, right? Off to 14. So we'll do seek 2, 14 by 2s. And we'll do the same thing for x end. And it's complaining about something. I must be missing a plus sign somewhere, or I must be missing parenthesis somewhere. Oh, and I forgot a plus sign at the end here. All right. Oop, that is off. So I think, 2 is the middle. So I went 2.5. All right, so we want to come up here and let's do 2.5 to 14.5. So that gets those positioned correctly on the x-axis. They could probably be a little bit longer. And I have it going down to what? 54. Let's try 53.5. I think that looks good. Now we need to make the width longer. And we use line width 1.5 down here for the y-axis ticks. And so let's go ahead and do the same thing here. And now I'm questioning if those are the right widths. I think it might want to be 1.25. So let's change that to 1.25. Those just looked a little bit too thick. I think that looks a lot better. So one thing I'm noticing is that because we turned off the clip on the x-axis, we're not going out far enough to the right, that this tick mark is right at, it must be 14.5, right? So let's make the x-axis limit go out to maybe like 14.6 and see if we can't get that tick mark to be attached to the axis. So let's do 14.6 here. That looks pretty good. We could probably even go to 14.7. And at this point, we're really just thinking about minutia. I think that looks good. So what I'd like to do now is to match the colors of my plot. So I open up my digital color meter, and maybe if I zoom in a little bit, get a better sense of the colors here. And so I'll go ahead and copy that and then come in to my scale, do a scale color manual, and we'll do values. And it's gonna be a vector with that color. And then this color, this grayish bluish color, plop that in and add a plus to that end. So that's like a pretty good color match. And I'm forgetting to put in the points, right? So let's go ahead and do that absolutely before we quit. And so we'll come back up, and here with geom boxplot, I'll do geom jitter, and let's see what happens if we add that. So what happens then is that we get our 3 points, but they're the same color as our box plot, and we want them to be black, right? And so that we can do color equals black to get the points to be black on top of our box plot, right? So very good. That was simple enough to add those black points. So I think I've done a good job of replicating their figure fairly well. Their version isn't what I would do if I was playing with these data. If you watch the next episode, I would show you what I will do with these data. Again, I kind of go back to the beginning where they've got these gaps between the two different treatment groups. I would keep those together, and instead of doing kind of this odd copper treatment variable like I did, I would put copper across the x-axis and then dodge by the treatment. They may have done that, but then they added that dodge width to get those boxes to be separated. But I don't know why you would separate them so far so that the distance between all the boxes is the same. You know, hopefully that makes sense. Anyway, just subtle little differences here and there, but on the whole, I think this was good. A couple points to drive home that we talked about: moving the legend in, getting rid of those grid lines, changing the size, the thickness, and the length of the tick marks, changing the margin around the tick marks, changing the sizes of all these things, basically making our own x-axis so that we could have tick marks between the different copper concentrations, right? The other critique I would have for this is the value of having a box plot when you only have 3 points, because the median, the min, and the max are going to be the 3 values of those 3 points. So I don't know. You do you. In the next episode, I think I will take on my preferred strategy, which would be to try to have a log 10 scale on the x-axis, and to probably represent these data as a line, right? And drawing a line through the median of the 3 points, perhaps including the 3 points, but having them be different colors and having them perhaps be a bit more of a muted color and sitting in the background compared to everything else that we're doing. Anyway, I think this is a really interesting plot to think about how we would make coming from the scientific literature. I would be really curious to see how they made this. If anybody knows the authors, if perhaps the authors are watching, I'd love to see your code to kind of see how closely what I'm doing aligns with what you did. Anyway, I'll stop there. But so that you don't miss my take on how I would repurpose this data to tell the same story, please make sure that you subscribe to the channel, tell your friends what we're doing here on Code Club, and I'll see you next time for another episode.